demonstration shows the reactions of lithium, sodium and potassium on heating in air, in chlorine and with water, and also shows some of their physical properties. We hope to show the similarities between the metals and also their trend in reactivity. Visibility can be a problem when doing these sets of experiments due to the very small amounts of metal that you'll be using. If you have access to a video camera and projector, this could work very well for your students to be able to see the small detail. There are a lot of observations to be made by the audience, and it is probably worthwhile getting them to draw up a table like this one to fill in while they watch. This could be extended to include room for predictions about rubidium and cesium. For greatest impact, do the reactions of potassium last, as they are the most spectacular? Periodic table order seems logical and builds to the most spectacular at the end. The first experiment is going to be heating in air. In preparation, we need to cut some of the metal, and this is an ideal opportunity to show some of the physical properties. First of all, you should point out that all the alkali metals that we're using are stored in oil. Take some of the metal out of the container using some tweezers and place on a tile. We're going to cut a small amount of the metal off this large chunk. As you can see with the lithium, it's quite difficult to cut. There we go. And you can see clearly the shiny silver surface. Over time, this does tarnish. I'm going to put this big chunk of lithium back into the container now. A second physical property that can be demonstrated is the ability of the metal, in this case lithium, to conduct electricity. I'm going to cut a small piece of lithium. There we go. Pick up the piece of lithium and drop it onto the Petri dish. Pass it round the class so that the audience can get an impression of how light in weight it is. Warn students not to touch the metal, taping the lid onto the Petri dish if necessary. Next you will need to cut a 3mm cube piece of metal in order to heat in air. Before we heat in air, you need to dry off the oil from the metal using some paper tissue. We no longer recommend using hexane to dissolve the oil because there have been fires when washing up due to some residues. Place a little bit of metal on a flat brick. When heating the metal, you need to use a roaring Bunsen flame and position the metal at the top of the blue cone, which is the hottest part. You can test the white residue with some moist indicator paper. Next we're going to look at the reaction of sodium metal. Again, indicate to your class that sodium is stored in oil to protect it from reacting with the moist air. Put a piece of sodium. Okay, so we need to cut a piece of sodium off this large piece. And you can see the lovely shiny silver surface that tarnishes much quicker than the lithium in air. That large chunk back in the oil. We can use a circuit tester to show that it conducts electricity. And cut off a small piece ready to heat in air. Dry off a piece of the sodium. And place it on a brick ready to heat. Again with a roaring Bunsen flame. You see it melting. And reacting with the air. You can again test the residue of sodium oxide with some moist indicator paper. This is a reaction of potassium in air. Again, the potassium is stored under oil. And we need to cut a piece off. You can see it's much easier to cut. This is much softer, and there's a shiny silver surface which tarnishes quickly in air, much quicker than with lithium and the sodium. Again, we can use a circuit tester to show clearly that it conducts electricity. And then we need to cut off a small piece to heat it in air. Very quickly melts. Just see a purple flame. For this you will need some previously prepared chlorine stored in a gas jar sealed with Vaseline. You should make sure that there is a green colour of the gas in the gas jar. You should also make sure that the opening of the gas jar is smaller than the brick, so you don't lose the chlorine out when you put it over the burning piece of metal. Heat the metal up till it's burning. See, that one goes much quicker. Lithium, dry it off with a paper towel. Put it in the water. When the reaction's finished, you can add some indicator . I'd add some indicator. To confirm that the gas is indeed hydrogen, add a very small piece of clean lithium to a little tap water in a boiling tube. Wait for a few seconds and pop the gas with a lighted taper. A squeaky pop.